In the blink demos, we used a driver for an LED. Defining an LED as a driver makes our code more sensible. You get to use methods like turn on and turn off, which should make more sense in context and make your code more readable than if you were using things like write 1 and write 0. Now let's have a look at a few more drivers. We'll look at the drivers for a direct pin, a button, an analog sensor, an LED, an RGB LED, a motor, and a servo motor. This isn't a complete list, by the way, of Cylon's built-in drivers. I'm showing all the non-device specific drivers that I think you'll be interested in. I have modified all of these examples to use an Intel Edison, though, assuming that's what you'll be working with as you follow this course. Keep in mind that some of these drivers, such as direct pin and analog sensor, are very generic, and they would work for just about any device you can plug into your board. The more specific ones, like LED and motor, are really just a convenience to give you some sensible methods for working with your gadgets. Like I said, the direct pin is a very generic driver. With it, you get to read and write from pins using either digital or analog values. The read function may take some time depending on the system this library is working on, so those functions are implemented with callbacks so they can be run asynchronously. The button driver is really simple. It has a single isPressed command that lets you query whether or not the button is pressed, and then events that fire when the button is pushed and when it's released. Using drivers with events like this is a slick way to do things as compared to constantly polling the pins to see if they've been pressed yet. The analog sensor, like the direct pin driver, allows for reading the analog value of a pin, but it also allows you to set lower and upper value limits and then fire events when the sensor value drops down to the lower or reaches the upper. Once again, it's a convenience, nothing more. It's very common in IoT projects to work with LEDs. It's a quick and easy way to get visual feedback to the user, so the LED driver comes in handy. It gives you good commands like turn on and turn off to use instead of the less logical digital write 1 and digital write 0. The toggle command is handy as well and eliminates the need to even check the state of the light before altering it. The current brightness to check the brightness level and the brightness command for setting it allow you to determine a PWM value. PWM stands for pulse width modulation. It sounds more complicated than it is. Let me explain. If you set the voltage level on a pin that's wired up to an LED to 0 volts, the light will be off. If you set the voltage to 5 volts, the light will be on. Now, if you very quickly modulate the voltage level by switching it back and forth from 0 volts to 5 volts, where half of the time it's at 5 and half the time it's at 0, then the LED will appear half lit. The effect on the LED is to cause it to glow proportional to the average voltage. If then you increase the amount of time the pin is held to 5, this is called increasing the duty cycle, then you increase the brightness of the bulb. With PWM, we can use a digital pin to simulate an analog voltage level, so it's really helpful. RGB LEDs are simply 3 LEDs, red, green, and blue, all set into one component. They have 3 different voltage levels that they can take to control each of the colors. Calculating the levels can become a bit of a chore, so the RGB LED driver lets you simply send a 6-digit hex color code to the color command, and it does the rest. If you're familiar with these 6-digit hex color codes from the web, then you'll be perfectly comfortable picking these color codes and calling the color command. The motor is pretty straightforward. Like the LED, it's helpful to have more meaningful command names like turn on, turn off, toggle, and speed. Servos are motors with a construction such that they're good at moving incrementally. They're good for actuating robot limbs, opening doors, and controlling visual indicators like the speedometer on your car. The commands in the servo driver allow for easily setting the desired angle, checking the current angle, and even checking an angle to see if it's a safe one for the motor. And that does it for a quick tour of the basic GPIO drivers.